We are back. Chapter 1, Section 4. We are going to be looking at powers and exponents today. A pretty short lesson. We also will review how to find the mean, the average of a data set. So I have two terms that I'm going to discuss here when I talk about a power and or exponent example. My bottom value here, the larger number, this is known as my base. The upper numerical value here to the upper right of my base, this is called my power or exponent. Power, exponent, those two terms are synonymous. They have the same meaning. So what this tells me to do here is I'm going to take my base value, in this case 3, and multiply it by itself, the power or exponent number of times. So I'm going to be taking 3 times itself twice. So 3 times 3, which we know, of course, is 9. I do not want to take the base times the exponent. No, do not do that. You're multiplying your base together, the power or exponent number of times. So, as I look at my first of 9 power and exponent examples here, I have base of 5 to the third power. So that tells me to take 5 times 5 times 5. Running down the line, 5 times 5 is 25. 25 times 5 is 125. What about when I have a 4 to the first power? Well, any base to the first power, you're just taking one of those bases. So I would just have a single 4. 100 to the first power, 100. Easy as that. Example 3, this is probably the most important example of the notes today. I have a minus sign in front of 2 to the fourth power, versus I'm comparing that to a minus 2 in parentheses to the fourth power. So in this case, I'm going to think of this minus sign, since it's not locked in parentheses here, as a famous F word. It's a floater. It is going to float on down to the final answer. So what I'm doing mathematically is taking the opposite of 2 to the fourth power. So I'm going to take 2 to the fourth, 2 times 2 times 2 times 2, and then take its opposite. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16's opposite, negative 16. So that's my result when my minus sign is not in parentheses. Versus, if my minus sign here, the minus 2, is in parentheses, this tells me to take negative 2 and multiply it by itself 4 times. So negative times negative times negative times negative will give me a positive result. Negative 2 times negative 2, 4. 4 times negative 2, negative 8. Negative 8 times negative 2, positive 16. So two very different answers there. Again, if the minus sign is not in parentheses, it's a floater. It needs to come on down to the final answer. Versus if it's in parentheses, multiply it out. So example 4, my minus sign is in parentheses, so I'm going to multiply the negatives out in each individual value. So I'll have negative 6 times negative 6 times negative 6. Negative 6 times negative 6, positive 36. 36 times negative 6 is a negative 216. Let's take a look here. We have your friend and mine, a floater. Floater, minus sign coming on down to the final answer. So I'm going to take the opposite of 10 squared. So the opposite of 10 times 10. 10 times 10, 100. Its opposite, negative 100. Fractions. Let's talk here. What do we have with 3/4 cubed? Well, I need to take 3/4 and multiply it by itself 3 times. 3/4 is my base, 3 is the exponent. So multiplying fractions, I'm going straight across, top times top times top. 3 times 3 is 9. 9 times 3, 27. Over 4 times 4, 16. 16 times 4 is 64. Similarly, with 3/7 squared, I'm going to take 3 over 7 and multiply that out twice. 3 over 7 times 3 over 7. 3 times 3, 9. 7 times 7, 49. So 9 over 49. Sorry, I got a little sloppy there. 8 and 9, we're going to look at fraction values in parentheses. Question 8 has a minus sign outside, so that'll be a floater. Question 9's minus sign is inside parentheses, so we'll multiply that negative sign out. 8 negative on the outside, 1/3 to the 4th. So I'm going to take 1/3 times 1/3 times 1/3 times 1/3. And then take its opposite. 1 times 1 times 1 times 1 is 1. 3 times 3, 9. 9 times 3, 27. 27 times 3 is 81. So 1 over 81, its opposite, negative 1 over 81. Finally, example 9, before we get to the mean calculations, averages, I'm going to take a look here and see the minus sign is inside parentheses. So I'm going to multiply the negative 3 over 5 times negative 3 over 5. I'm keeping that minus sign in each of the individual values. So multiplying negative 3 times negative 3, I'm going to get positive 9 over 5 times 5, 25. So final result, positive 9 over 25. I'm going to get the mean examples set up, and we will go through those here in just a second. All right, let's finish off with reviewing how to find the mean of a data set. I'm going to look at an example here where I have 2, 4, 6, an even number of measurements, and then example 2, I have 2, 4, 5, an odd number of measurements. So again, mean, that's the same as finding the average of a data set, and that is found by taking all your values, adding them up. We use the 3-letter S word, that means add them up, sum, divided by how many numbers you have, and we use the word quantity to describe the count or the number of numerical values that we have. So first example I have is 8 plus 10, 18, plus 7, 25, 25 and 9, 34, 34 and 9, 43, 43 and 6, 49. So I'm going to have 49 divided by 6. This is not going to be a whole number. So 8 times 6 is 48, 8 and 1/6, which if you're a decimal person, I believe is 8.16 repeating. All right. Again, if you are wondering, well, what do I round to? Nearest hundredth is okay too. So 8.17. Any one of these 3 answers is groove A. Heading to example 2, I've got some larger values here. 5 looks like percentages. So we got 90 and 95 is 185. 185 and 80 is 265. 265 and 75 is 340, plus 100 would be 440. So there's my sum divided by the quantity of 5. 440 divided by 5. This is a little cleaner. We get the DeLorean value for all you Back to the Future fans. Yes, the flux capacitor will work when you hit 88 miles per hour. 440 divided by 5 is 88. No fractions, no decimals. Life is good. Thanks for your time. 1-4 is complete.